Okay, we're going to work on a few problems here. The for this section 3.4, showing that the statements are equivalent to each other. So let's work through a couple of exercises from the handouts. That's what these videos will be, basically talking about the things that we would have covered in class if we were there. Okay, so let's start with this first one. We're trying to show that, let's see, P implies Q. If P, then Q. This, let me get rid of that little. That should not be there. Oh gosh, it won't go away. Okay, well, we'll have to live with that. This guy here should not be there. Okay, so we're trying to see if these two statements are equivalent to each other. So this is example 1. So what we do is we set them up in a table, truth table, and we'll compare the two when we're done. Okay, so now this is just your standard conditional statement, and we know that that's only time that is false is, right? You know it right here. All the other cases are true. Now here we have a disjunction, and I could just read these negations of P right off of here, or you could put them down right underneath so you can see it. We could probably make the jump here. I'll write it here, not P, which would be false, true, and true. And then Q, I'll just copy over true, false, true, false. And then this is an OR statement, the disjunction. Only time it's false is if you have two falses. So here's a false right here. And the rest of them are trues. So true, true, true. So when we compare these two lines, I mean, this is like two separate statements in the same truth table, basically. We've got this statement, and we're comparing this one to it. So instead of building two separate truth tables, we just have one with two separate statements in it. And these are the final columns of each one. They are identical. That means that the two original statements, this statement is equivalent to this statement. That's the one that's probably the most useful of many of these that we're going to see. So we kind of single it out as it being important. It's the relationship, how a conditional is equivalent to a disjunction and how to make that conversion from one to the other. So sometimes you'll be able to rewrite and use one in place of the other. Use the left side of the statement instead of the right side in the process of showing other statements and converting other statements. So this first one here, example 2 now, we have another one. So let's see what happens with that. Let's see how that comes out. Okay, so we're over here now. Let's see. So here's our next problem. This one we're going to convert. And here we're going to use De Morgan's laws, which basically says that Let's say there's a pair of them. And you can see these in the text. I'll write it over here. First one looks like this. It can be shown, and you can use the truth table to do this. That these are equivalent statements, and it can also be shown that this, the negation of the disjunction, is equivalent to the disjunction. Okay, so over here now, that means we can write this one. Let's see how simple we can get these and see if we can get to a point where they look the same. We might have to change both sides of this statement, of the equivalent statement. Now this one could be written as not P or not Q using this first rule here. If I give this a number, if this is 1 and this is 2. So by using statement 1, I could write it like this. And now over here, let's see, this one, we could write as not Q and P using statement 2. But as you can see, these are not the same. This is a disjunction. This is a conjunction. They're not the same, so not equivalent. This one over here now, I can write this one. This is, again, this goes up to the box up here. We can start inside, see, because this one over here, it's possible you could find different ways to write this right side and make it look like the left side, but let's start with the more complicated one here. And I'll change on the inside now, change this to a not P or a Q. That's using my conversion up here, disjunction, or by conditional to the disjunction, okay? And then from here, I can write, using one of De Morgan's laws, the second one here, I can write this as negation of not P, negation, that makes it a P. This becomes an and, this becomes not Q. Then I look over here and I say, these are basically the same as P and not Q is the same as P and not Q. So we do have equivalence on that one. I'll come over to this left one over here. Finally, example 3 now. Can we make this left side look like the right side? Well, I see that the if-then statement is basically the same except for this antecedent. So maybe I could change these to look this way. So let's start in here. This one, we could say, we could do this 2 ways. Why don't we go to using the box formula up here. Let's write this as, this is our first statement. So this would be not P or not Q or R. So that's using this first, the box here. So I negate the antecedent and I link it with an or, and then I bring down the consequent. Now this side over here, I can use one of De Morgan's laws, the second one. Write this as P and Q. This is or R. Now is that the same as this one? Well, let's check. Again, I'll negate this, which will become Q and P, because negation or the R. So that's basically the same. I mean, with the transposition of Q and P, it is still reading the same thing. So again, we have equivalence. Okay, the last one over here. Let's see. We can, we'll change this since this is This doesn't have a conditional in it. We'll get rid of this conditional. So this will become not. We want to not P, which is not P is a P or a Q. And that becomes not P and not Q, which we see is what's on the right side here. So again, we have another equivalent statement.